Good afternoon. This is David de los Reyes. Good afternoon. This is David de los Reyes. For today, my topic will be: has anybody seen an alternating current? Okay guys, I will now try to bring out the actual view of an alternating current. Alternating current is the one coming out from our utility companies. Alternating, try to see my oscilloscope guys. That's the view of alternating current. Up, down, up, down. Actually, I could not bring out the actual graph of a 120 volts alternating current. It's too big for the oscilloscope to accommodate it. So what I did, I got a variac here. I got a variable transformer here. This is a variac where I could vary the value of the one coming out from this outlet here. Actually, I set the voltage to 31.44 volts AC. At this volts, we could see the actual top portion, the positive alternation and the negative alternation. Okay? But if I will set it to 120 volts, we could not see it. It's too big. Right? So for 31.42 volts AC, okay, we could see the actual value or the graph of the positive alternation and the negative alternation. Okay. The terminal of my oscilloscope is connected to the two terminals coming from the utility line. We don't have any polarity. Actually, you could connect it. Don't be mindful of the positive and negative. For alternating current, it doesn't matter. Okay, so my ground is on line number 1, and the other probe of my oscilloscope is on the other line. Okay, it's alternating current, so it doesn't matter. We don't follow any polarity. Okay, then I try to tap my voltmeter on the AC line, okay, and what comes out is 31.44, and exactly as it is, that's the graph of the 31.44 volts AC. Okay? This is the positive alternation. It corresponds to that one. I will try to make this steady, you know. See? You got the positive alternation and the negative alternation. So just in case, guys, you are electrocuted, that's the nature of the current going into your body. It's alternating current. It could kill you. So don't play with it, okay? For us who know to handle alternating current safely, okay, we can do it. But for those who don't know anything, don't try to do it, okay? You will be killed. Okay? So actually, that's alternating current. You got the positive alternation, negative alternation. What we did yesterday, we eliminate the negative alternation. Okay? So what's coming out are actually the pulsations. Okay? And that is termed pulsating direct current. To eliminate the negative pulsations, it's the topic yesterday. It's that's the use of the rectifier circuit. So what we are rectifying are actually alternating current coming from the utility line. You must have to eliminate the negative alternation for us to give us a pulsating direct current, okay, to power up our gadgets. But that's not only the thing that that's needed, okay? For digital circuits to use the rectified current, the pulsation should be smooth. Okay, so later on my next topic, I will try to bring out a pulsating direct current in which the pulsation is big. Then I will try to smoothen that out by placing something on the circuit. Okay, so you know how to, for those who don't know anything yet about rectification, okay? You try to place something on the circuit to smoothen out. Actually, engineers do that, and us technicians and engineers, we could do that. Okay? So guys, if ever somebody asks you, have you seen a alternating current? I've seen it on YouTube, okay? It was done on a demo, live demo, okay? And that's it. That's the graph of an alternating current. Positive alternation, negative alternation. For here in USA, the alternation, the direction of the current changes from upward to downward 60 times per second. 60 hertz. That's the so-called 60 hertz. Okay? But don't play with it. It could kill you. It could kill you. The only thing I'm showing you this is because sometimes we may, for the layman's man, they don't know what's the shape of an alternating current. That's the shape of the alternating current. So just in case you got electrocuted, that's the one coming into your body. That's the one. It's very hurtful. It could kill you, right? So for those technicians, okay, we know this one already. We know how to handle ourselves safely, you know. This is just for a know-how for the layman's man, okay? That's alternating current. At that peak-to-peak, the value is only 31.53 volts. Because if I will show you 120 volts, it's too big a graph, okay? It cannot be seen on the oscilloscope. So what I did to show the positive alternation and the negative alternation, I got a variable transformer over here. I decreased the input voltage to my oscilloscope, okay? I make it only 31.54 volts. So it will be accommodated by the screen of my oscilloscope, okay? If I will not use a variable transformer, the graph is very big. Okay, so you cannot see the positive alternation and negative alternation. So to eliminate that one, I decrease the input voltage so it could accommodate the graph of the positive and negative alternation. So that's it, guys. That's the view of an alternating current. So if somebody asks you, have you seen an alternating current? That's it. Okay? It is this. If we are teaching on the board, we do like this. We say this is the volt. The abscissa is the AC voltage. The ordinates is the time. So as time passes by, we got the positive alternation, negative alternation. Positive alternation, negative alternation. What's the meaning of that? If we got a load here, for the positive alternation, the current moves like this. For the negative alternation, it moves like this. So alternating current passes through the load, okay, in two directions. Downward and upward. Downward and upward, and at the rate of 60 times per second. For direct current, okay, it moves only in one direction, okay? If it's downward, it's downward. Okay? And it is termed direct current. It doesn't alternate. It doesn't reverse polarity. But for alternating current, for the positive alternation, it be like this. Negative alternation, it's like this. Then keep going on. 60 times per second here in the USA. That's alternating current. Alternating current. Okay? It can kill you. See? Okay, that's it, guys. Good afternoon, Los Angeles.